Okay, so section 2.7 is graphing inequalities. So this is going to put together a lot of things that we've learned already. Like, you guys know how to graph inequalities when it was just on a number line. Do you guys remember that? You don't have to draw this, but we would fill in and shade on the left, and we'd write it in interval notation as negative infinity to whatever number that is, bracket. So you've done that on a number line, but now we're going to talk about on a Cartesian coordinate plane, so with the x and y axis. So a linear inequality is an inequality in two variables, so x and y, that can be written in one of the following forms. So you can have y is less than mx plus b, y is greater than mx plus b, y is less than or equal to mx plus b, or y is greater than or equal to mx plus b. So it looks just like your linear equation, but instead of equal, you have less than, greater than or equal to, less than or equal to. Okay, to find where to shade an inequality, you're going to pick a point. So pick a test point and plug in. So you're going to plug it into the inequality and see if your inequality is true. If it is, you shade that point. So you're going to shade whatever side of the inequality it was on. Notice this point, it can never be on the line, so not on the line. The boundary line is dotted if you have greater than or less than, and it's solid if you have greater than or equal to or less than or equal to. So dotted is the first one, and solid. Okay, so basically you graph the boundary line. So you're going to graph the boundary line. I'm going to write out the steps here. Which was just with an equal sign, so y equals x plus 5. But in our case, since it was just greater than, that means that line is not going to be filled in, the actual equal to line. So this is going to be dotted when we draw it. So that's our first step, so just graph the boundary line. So how would we graph y equals x plus 5? So let's see, Caitlin, what would you do? So y equals x plus 5.
You go up
Up 5, 1, 2, 3, 4, 5, and draw your first point, and then where do you go?
you go up 1
Up 1 over 1, up 1 over 1, because the slope was 1 over 1, right? This line is going to be dotted. A lot of you guys will forget, and you'll just go through and erase part of it. I always did that when I was in high school. So that's our boundary line. So then we determine which side do we shade on. So pick a point not on the line. If 0, 0 is not on the line, that is always the easiest one to pick. So in our case, 0, 0 is not on that boundary line, so I'm going to pick that. And I'm going to test it. So I test it in my original. So my original said 0, well, it said y. I'll write out the y part for you. It says y is greater than x plus 5. So I'm going to plug in 0 for x, 0 for y. So I get 0 is greater than 0 plus 5. So I just plugged in 0. So 0 is greater than 5. True or false? False. So that means 0, 0 is not in the shaded area. So 0, 0 is not shaded. Okay, so here's where 0, 0 was, so don't draw it, but that's where 0, 0 was. So that's not going to be on the shaded side. So that means we're going to shade on the other side of our dotted line. So we're going to shade above. Now don't get crazy with your shading, because what happens is people will like do a mess. So they'll fill it in real dark like that. And then they realize they shaded the wrong side and they have to erase that big mess. So don't do that. Oops. So I usually just kind of, I do like little lines like that. And you can use colored pencils. Some people use highlighters, but like I said, if you mess it up, then that's kind of hard to change. So colored pencils are usually the best. Make sense? Okay, stop. Okay, so let's do 2x minus 3y is less than 6. Now, I give you a hint here, and I say it might be useful to use what we call the intercept method. Do you guys remember the intercept method? When you find the x-intercept, y-intercept? No. So our boundary line is 2x minus 3y equals 6. So we're going to find the x-intercept and the y-intercept of that. So in class we said this is like the easiest method to do in your head, because if you're finding the x-intercept, you're plugging in 0 for y. And you can do that in your head. It's like you're covering up the y part. So you have the equation 2x equals 6. So that means x is 3. So that is a point. We plugged in 0 for y and got x was 3. So it's 3 for x, 0 for y. 3, 0. Same thing for the y-intercept, only now it's going to be 0 for x. So it's like you're covering up the x part. Remember I said you can just cover it up with your finger. And your new equation is negative 3y equals 6. So y has to be negative 2. So that's the point 0, negative 2. And all of that can be done in your head. You don't have to write down those steps. So you have 3, 0, 0, negative 2. Is my line going to be dotted or solid? Dotted, because it was just less than. It wasn't less than or equal to. The equal to part is actually filling in the whole line. So we're not filling in the line. So it's dotted. So draw your dotted line. And then you determine where to shade. So 0, 0 is not on our line, so we can pick it. So I'm going to have 0, 0. I plug it into my original. So instead of 2x minus 3y is less than 6, I have 0 minus 0 is less than 6. That's true. So that means 0, 0 is shaded. So our point 0, 0 is above the line, so we're going to shade above the line. Okay, the next one is y equals 6. Well, it's actually y is greater than or equal to 6. But what does y equals 6 look like? It's a horizontal line through 6, right? So you're going to go up 1, 2, 3, 4, 5, 6, because all the points on this line have a y value of 6. You have 0, 6, 1, 6, 2, 6. I knew it was solid because it was greater than or equal to, and equal to means I fill in the line. Now this is kind of tricky. You can test 0, 0. You get 0 is greater than or equal to 6. That's telling you 0, 0 is not shaded. But what I think of is I think of where are all of my y values bigger than 6. So all of the points that have y values bigger than 6 are above the line, right? So that's what you're doing. So you can actually write out the step where you test 0, 0. Or you can think of it logically, like all these y values are bigger than 6. I have 7s, 8s, 9s. Okay, so that's that one. Okay, so the next one looks a little hard. So I have 3/4 times 8 minus, or times 8x minus 2y is less than or equal to 6. So on this one, let's go ahead and try to simplify first. Now, do you guys like the intercept method, or do you like the y-intercept, or the slope-intercept form? Like y equals. So how many of you want to do intercept method? 4 of you, 5, 6. How many of you want to do y equals? So only Sarah. So we'll do the intercept method, but I can kind of show you how you do both of them. Okay, so on this one I have 3/4 times 8x minus 2y. So I'm going to multiply my 3/4 in, or you can get rid of the 3/4. How can we get rid of the 3/4? Yeah, multiply by 4/3. So let's do that. So on both sides I'm going to multiply by 4/3. So on the left I just have 8x minus 2y is less than or equal to. Then I have 6 times 4/3. So think of it as 6 over 1 times 4/3. So it'd be 24 over 3, which is 8. Or you can do the canceling trick. 6 and 3 make 2 and 1. So 2 times 4 is 8. Okay, now you're ready for the X-intercept, Y-intercept method. So X-intercept, you plug in 0 for y. So think of covering up the y part. You'd get 8x equals 8. So x would be 1, right? Y-intercept, you plug in 0 for x. So think of covering up the x part. So I have negative 2y equals 8. And don't worry about the less than or equal to, just think of the boundary line as it being equal to. So you get y equals negative 4. So I have 1, 0, 0, negative 4. My line is going to be solid because it was less than or equal to. So equal to fills in the line. Like that. So now you're ready to test. So we're going to test 0, 0. So when I test 0, 0, I have 3/4 times 0 minus 0 is less than or equal to 6. So 0 is less than or equal to 6. That's true. So that means the point 0, 0 is shaded. So here's where 0, 0 was. So shade above. Okay, now the other way was to actually solve for y. So if you actually solve for y, you'd get rid of the 3/4 by multiplying by 4/3 like we did. So I'd have 8x minus 2y is less than or equal to 8, like before. I'd subtract my 8x over. I'd divide by negative 2, but what happens there? If I divide by negative 2, what do I need to do? Right, since it's an inequality, you need to flip the sign. So you'd have 4x minus 4. All right, let's see if that's the graph we actually graphed. So 4x minus 4. So negative 4 is my y-intercept. So see how we went down 4 and have that point. And then your slope was positive 4. So you go up 1, 2, 3, 4 over 1. It's the exact same line. Now, the convenience of solving for y on these, so if you guys do this, see how it says y is greater than or equal to? When y is greater than or equal to, that means you shade above. So you can kind of skip out on doing the test point, because when it's greater than or equal to, you're going to shade above the line. If it was less than or equal to, you'd shade below, or less than. So let's see if it worked out in our other ones. So if I go back to my first one that I did, see how I had y is greater than x plus 5 on the first one, and we shaded above. So our line was here, and we shaded above it. All right, so that worked out. Okay, number 5. So a school carnival charges $4.50 for adults and $3 for children. The school needs to make at least $135 to cover their expenses. Using X as the number of adult tickets and Y as the number of child tickets, write and graph an inequality for the amount the school needs to make on ticket sales. Okay, so we're going to let X be the number of adult tickets. And Y is the number of child tickets. So it's $4.50 for each adult, so 4.50x, plus $3 for each child. Where's the inequality? Do I just say equals 135? Yeah, that is the amount of money you make, and that amount of money needs to be greater than or equal to 135, right? And that's because we use the word at least 135, so at least. All right, so we're going to graph it. So let's go ahead and do the intercept method. These intercepts are a little bit harder to do in your head, so you can use a calculator. So our x-intercept, if I plug in 0 for y, so I'm imagining this y part's gone, so I'd have 450x equals 135. So I'm going to do 135 divided by $4.50, so I get 30. So I have 30, comma 0. My y-intercept, plug in 0 for x, so this x part's going to be gone. So I have 3y is greater than, or well, equals, we're just talking about the boundary line. So 3y equals 135, so divide by 3. So I get 45. Okay, x is the number of adult tickets. Y is the number of child tickets. So you should always label. We have 30, comma 0, so I'm going to go by tens, 10, 20, 30. And draw a point. And I have 0, 45, so go by tens, 10, 20, 30, 40, 50. I ran out of room. So right there. And then connect your points. It's solid because it's greater than or equal to. Okay, and then we need to figure out where to shade. So if you plug in 0, 0, you get 0 plus 0 is greater than or equal to 135. Okay, so 0 is greater than or equal to 135 is false. So that means 0, 0 is not shaded. So we're going to shade above the line. And that should make sense to you. Because any point in that shaded region, like let's say I found 20, 30. So this point 20, comma 30 is in that shaded region. That is saying if you sell 20 adult tickets and 30 child tickets, you will make enough money. So any point in that shaded area will be enough money. Doesn't it make sense that it would be above that line? Because things that are above that line are like, what if they sold 500 adult tickets and 500 child tickets? Yeah, they're definitely going to make enough money. Do you guys see? All right. So B, if 25 child tickets are sold, how many adult tickets must be sold to cover expenses? Okay, so that's just using your inequality that we had. So 450x plus 3y is greater than or equal to 135. And we're plugging in y, because child was y, right? So plug in y equals 25. So I'm going to subtract 75 over, because that's 75. So I have 135 minus 75, so 60. So I get 450x is greater than or equal to 60. Divide by $4.50. So I get x is greater than or equal to 13.3 repeating. Okay. If you guys circle that answer, I'll count it wrong. So why is that wrong if you say it like that? Yeah, Kern? Yeah, you can't sell 13.3 tickets, right? So I would say at least 14 adult tickets. Okay, one more. Okay, so graphing absolute value inequalities is just like graphing linear inequalities. So you're going to graph the absolute value just like normal, and then decide if the boundary is solid or dotted, and then we test a point. But with absolute values, remember you're going to have that V shape we talked about yesterday. So you're going to have a V shape. So our boundary is y equals absolute value of x minus 2. So we need to know how to graph that. So let's do a t-table. Plug in positives and negatives when you have absolute values. So if I have the absolute value of 0 minus 2, I get negative 2. 1 minus 2 is negative 1. 2 minus 2 is 0. If I plug negative 1 in, I get 1, right? Positive 1 minus 2, so negative 1 again. And if I plug in negative 2, I get 2 minus 2, which is 0. Okay. So I have 0, negative 2. 1, negative 1. 2, 0. Negative 1, negative 1. So now I can start to see my V shape. Negative 2, 0. Is it solid or dotted? Solid, right? It's solid because it was greater than or equal to. So because of the equal to part, it's filled in. Okay. Okay, then we decide where to shade. So again, 0, 0 is an easy one to shade, or an easy one to pick. As long as it's not on your boundary curve or boundary line or whatever. Okay, if it was on your boundary, do you guys know what you do? So what if 0, 0 was on the boundary? Yeah, pick another one that's not. Like you could pick 0, 2. Just make sure you're plugging in the correct values for x and y. All right, so test point. So I have 0 is greater than or equal to the absolute value of 0 minus 2. So 0 is greater than or equal to negative 2. True or false? True. So 0 is bigger than a negative number. So that means 0, 0 is in the shaded portion. So that means with our V shape, I'll kind of extend it here, you're shading on the inside of the V shape because 0, 0 is inside that. Yes? Yes, since it's greater than, it would be above, right? But you have to have y by itself in order to do that trick. Like you can't have like negative 2y is greater than or equal to. You have to have the y part by itself. Okay, if it had not worked out, then you would shade below, right? So everywhere outside of that V shape. Oops.